today we are going to look at the Unit 10 review for the applications of quadratics. So 1 through 4 all deal with perimeter and area, which is the most recent lesson that we did. So that remember when we talk about perimeter, we're talking about the distance around. So if I want to find the perimeter of this pentagon, I'm going to add all my sides. So I have 2 that are 4x plus 3, and I have 2 that are 6x minus 8, and then I have the 3x at the bottom. So right here I'm going to go ahead and distribute that 2 through, so 2 times 4x gives me 8x, and 2 times a positive 3 gives me 6. Then I have 2 times 6x, which gives me 12x, and then 2 times a negative 8 gives me a negative 16, and then plus 3x. From here, I'm going to combine my like terms. So when I do that, I'm going to look at all my x's, and I'm going to combine those. So 8x plus 12x gives me 20x, plus 3x gives me 23x. And then I'm going to combine my constants. So I have a 6 and a negative 16. So that's going to give me a negative 10. So that is my perimeter. Okay. Number 2, they're telling me that my perimeter is 15x plus 3, so find my missing side. We're just going to call that side y. The 2 sides that I do have right now, 4x plus 5 and 8x minus 3, and then my unknown. Again, I'm going to do the same thing. So I have a 4x and an 8x, which gives me a 12x. And then I have a 5 and a negative 3, which gives me positive 2. And then I have that unknown side. But if I know my whole perimeter is 15x plus 3, so 15x plus 3 is equal to my perimeter, then I can get y by itself simply by moving the 12x over and then moving the 2 over. So this unknown side becomes 3x plus 1. Okay. All right, number 3. We have a rectangle and we're told that the perimeter is 126. So we want to find the length and the width. So remember that perimeter is all the sides. So I have 2 that are 2x minus 6, and I have 2 that are x plus 3. So my perimeter is 4x minus 12, and then 2x plus 6. Just like we did above, I'm going to combine my like terms. So 4x and 2x gives me 6x. And then negative 12 and a positive 6 is going to give me a negative 6. So that is the perimeter. But I'm also told that the perimeter is 126. So I'm actually going to replace the p with 126 and solve. So add 6. Divide by 6. So x is equal to 22. So that is x. That's not my length and width. Over here my width is x plus 3, which is going to give me 25. And my length is 2 times x, 44, minus 6, which is 38. So there's my length and width. On number 4, we're told that a rectangular pepperoni and mushroom pizza has a length of 2x plus 16 and a width of 3x minus 5. So find the area. Remember the area is length times width. So I have 2x plus 16 times 3x minus 5. This goes back to when we multiplied our binomials or polynomials. Remember that we can use the box method. And we're going to say 2x plus 16 and 3x minus 5, and then fill in. 3x times 2x gives me 6x squared. 3x times 16 gives me 48x. 2x times a negative 5 gives me a negative 10x. And negative 5 times 16 gives me a negative 80. So when I combine my like terms, I have 6x squared plus 38x minus 80. And that is the formula that describes the area. 5 through 10, you are simplifying the radicals. You should get no decimals through here. So this is where you're breaking this down into prime factorization. So if I look at number 5, it's the square root of 64. Well, if I think back to my perfect squares and my perfect square roots, this is already a perfect square root. The square root of 64 is 8. Okay, so I don't need to simplify that one as far as come over and divide it down, because that is a perfect square. 150, however, is not. So I'm going to come over here. Since it's an even number, I'm going to divide by 2. I get 75. Well, 75 is no longer even, so I can't divide by 2 anymore. Instead, I'm going to divide by 5. So when I divide by 5, I get 15, which is divisible by 5 again, and then I get 3. So that gives me 2 times 5 times 5 times 3. I'm looking for the pairs. Whatever I circle in is a pair goes on the outside, and whatever I didn't circle goes back together underneath. Okay. 7. Again, 121 is a perfect square, so the square root of 121 is 11, so I don't need to divide that one down. 108, I'm going to start by dividing by 2. I'm going to get 54, which is still divisible by 2, and I get 27. But 27 is no longer divisible by 2, so now I'm going to move to 3. 27 divided by 3 is 9. Divided by 3 is 3. So when I rewrite it, I have 2 times 2 times 3 times 3 times 3. So we're looking for pairs. So I have a 2 and a 3. Remember, whatever I bring out gets multiplied, and whatever I don't circle goes back underneath. Okay. All right, so 20 is even, so I'm going to start with a 2. 10 is still even, so I'm going to divide by 2 again, and I get 5. Well, 5 is prime, which means I have 2 times 2 times 5. I circle my pair. That's what's going outside, and whatever I didn't circle stays underneath. And 63. So 63 is not an even number. It's not divisible by 2, so I'm going to move to my next one and see if it's divisible by 3, which is 21. Divide by 3 again, which gives me 7. So I have 3 times 3 times 7. I have a pair of 3s, so the 3 comes out, and the 7 stays underneath. Okay. All right, let's look at the next page. So on 11 and 12, you are just putting these directly into your calculator to get a decimal approximation, and then you are going to round to the nearest tenth. So remember that my calculator will do fractions, so alpha y equals enter, and then I'm just going to type 3 plus the square root of 76 divided by 12. If I'm rounding to the nearest hundredth, I'm going to the second decimal place. Well, so this 6 afterwards is going to make this 7 and 8. So I get 0.98. Okay. Let's do the same for the next one. So alpha y equals enter. 1 minus 3 times the square root of 28. All of that divided by 5. And this time I'm going to get negative 2.97. On 13 through 16, these are solving by square roots, which means you want it to be a squared equals a number. Once you have that, you square root both sides, and you get a is equal to plus or minus the square root of c. So I need the squared term by itself first before I can do anything. So right here on 13, I get k squared equals 67. The squared term is by itself. So I'm going to go ahead and square root both sides. I'm going to get k is equal to plus or minus the square root of 67. And then I'm just going to find the square root of 67 in my calculator. Again, I'm rounding to the nearest hundredth, so 8.19. right, on 14, my squared term is not by itself yet. I still have something in front. So I'm going to go ahead and divide by 2. So I get n squared equals 98. Now my squared term is by itself. So I'm going to go ahead and square root both sides. On the left, I'm just going to get n. And on the right, I get plus or minus the square root of 98. But then we're going to find the square root of 98. Ooh, so I get 9.90. Okay. On 15, it's not by itself because I have this plus 10. So I need to get rid of this plus 10. Well, right now it's adding, so to move it, I'm going to go ahead and subtract it. So I get x squared equals 18. So now the squared term is by itself. I'm going to square root both sides. So I get x is equal to plus or minus the square root of 18. So x is equal to plus or minus 4.24. On 16, I have a squared equals 49. So squared term is already by itself. So square root both sides. And I get plus or minus the square root of 49. But what is the square root of 49? 7. Okay? All right, 17 through 20, you're going to use the quadratic formula. It is right here for you. Remember that before you can use this, you need ax squared plus bx plus c equals 0. Your equation must equal 0 before you can use the quadratic formula. So look at number 17. I have x squared minus 5x equals 10. That is not equal to 0 yet. So I need to move this 10 to the other side. So x squared minus 5x minus 10 equals 0. Now it's equal to 0. Now I can say A, B, and C. So when I plug these in, B is a negative 5. So I plug in a negative 5. And then I have a negative 5 squared minus 4 times A, which is 1, and C, which is negative 10, and 2 times A. A negative 5 is going to go ahead and give me a positive 5. 5 squared gives me 25. 4 times 1 times negative 10 is going to give me a positive 40. All of that divided by 2. So I get x is equal to 5 plus or minus the square root of 65 over 2. Which now, I need to split this up. I'm going to have x equals 5 plus the square root of 65 divided by 2. And x is equal to 5 minus the square root of 65 divided by 2. Go ahead and put this into your calculator. So alpha y equals enter. So 5 plus the square root of 65 divided by 2. So 6.53. Then I want to change that to subtraction. So 5 minus the square root of 65 divided by 2. I get negative 1.53. So those are my two values for x. Okay. On number 18, I have 4x squared minus 6x minus 1 equals 0. So it is already equal to 0, so I don't need to move anything around. So I have A, B, and C. So x is equal to a negative b. b is already a negative 6, so that's going to go ahead and make it a positive 6. Plus or minus the square root of 6 squared minus 4 times a times c. All of that divided by 2 times a. So 6 plus or minus the square root of 36 plus 16 divided by 8. So x equals 6 plus or minus the square root of 52 divided by 8. Now split it up. So x equals 6 plus the square root of 52 divided by 8. And x equals 6 minus the square root of 52 divided by 8. So alpha y equals, enter, 6 plus the square root of 52 divided by 8. So 1.65. and then 6 minus the square root of 52 divided by 8, negative 0.15. Okay? All right. On 19, not sure if I'm going to have enough room, but it is already equal to 0, so I have a, b, and c. So x equals a negative b, but b is already a negative 22, so positive 22 plus or minus the square root of 22 squared minus 4 times a, c, all of that divided by 2 times a. So 22 plus or minus the square root of, so 22 squared is 484. Minus 4 times 15 times 5 gives me 300. All of that divided by 30. So x equals 22 plus or minus the square root of 184 divided by 30. So from here, split it up. So x equals 22 plus the square root of 184 divided by 30. And x is equal to 22 minus the square root of 184 divided by 30. So alpha y equals, enter, 22 plus the square root of 184 divided by 30. So 1.19 and 22 minus 0.28. All right? All right, on 20, I have 5x squared minus 8x equals 11. So again, it doesn't equal 0, so the first thing I need to do is move that 11 over. So 5x squared minus 8x minus 11 equals 0. Now I can do a, b, and c. So x equals negative b, but b is already negative 8, so 8 plus or minus the square root, 8 squared, minus 4 times a, c, all of that divided by 2 times a. So 8 plus or minus the square root of 8 squared is 64. 4 times 5 times 11 is positive 220. All of that divided by 10. So 8 plus or minus the square root of 284 divided by 10. And now split it up. X equals 8 plus the square root of 284 divided by 10. And x equals 8 minus the square root of 284 divided by 10. So let's put it in. Alpha y equals, enter, 8 plus the square root of 284 divided by 10. So 2.49. And then go ahead and make that subtraction. 8 minus, and I get negative 0.89. Okay? Alright, so that was using the quadratic formula. On 21 through 24, you can choose the method you would like to use in order to solve these. You can factor, you can graph, or you can just use the quadratic formula. Right here, I have 4x squared minus 12x. It's a binomial, and they both have an x, which I would factor. More specifically, I would use GCF. So remember that I have my box. So I have 4x squared, and I have a negative 12x. What is the biggest number that 4 and 12 both have in common? 4. I have an x squared and an x, which means they both have an x in common. Now I'm going to fill out my top. What would I need to multiply 4x by to get a 4x squared? X. What would I need to multiply 4x by to get a negative 12x? A negative 3. Which means I have 4x times x minus 3 equals 0. Once it is factored, I set each factor equal to 0 and solve. So right here I'm going to divide by 4. But 0 divided by 4 is just 0. Right here I'm going to add 3, so I get x equals 3. So those are my two solutions. On 22, I am looking for, if I was going to factor it, it is a trinomial, so I'm looking for the factors of 9 that subtract to give me 4. My only factors of 9 are 1 and 9 and 3 and 3. So none of those subtract to give me 4, which means I can't factor. I could graph, or I can just go straight to my quadratic formula. So A, B, and C. So x equals a negative b plus or minus the square root, b squared minus 4 times a times c, all of that divided by 2 times a. So I get negative 4 plus or minus the square root of 16 plus 36 divided by 2. So negative 4 plus or minus the square root of 52 divided by 2. We'll split it up. So x equals negative 4 plus the square root of 52 over 2. And x equals negative 4 minus the square root of 52 over 2. So in my calculator, alpha y equals enter. So negative 4 plus the square root of 52 divided by 2. So right here I'm going to get 1.61. And then if I make that subtraction, I get negative 5.61. So 1.61 and negative 5.61 are my two solutions. Okay. On 23, if I look at that, I have 4x squared minus 49 equals 0. So I only have two terms. Again, it's a binomial, but this time they don't both have an x inside them, which means this is factoring, more specifically dots. Alright, so I know I'm going to put my parentheses. One of them is addition and one of them is subtraction. What is the square root of 4x squared? 2x. And what is the square root of 49? 7. Once I have it in factored form, I'm going to set each factor equal to 0 and solve. So right here I'm going to subtract 7 and then divide by 2. So x equals negative 7/2. And over here I'm going to add 7 and then divide by 2. So I get a positive 7/2. So I get 7/2 and negative 7/2. If you want to make those a decimal, 3.5 and negative 3.5, that is also fine. Alright, on 24, my equation is not even equal to 0 yet, so I can't do any method. So the first thing I need to do is go ahead and subtract 1 from both sides. So I end up with 4x squared minus 8x minus 5 equals 0. This is a trinomial. I can see if it'll factor, so I have to do 4 times 5, which gives me 20. Now I'm going to list all those factors of 20. And I'm looking for 2 that subtract to give me 8. Okay. So now I'm going to fill in my box. So I have 4x squared and negative 5. I need the 2 and the 10 to subtract to give me a negative 8, which means the 2 is positive and the 10 is going to be the negative. Now you're going to GCS each row. So 4x squared and a negative 10x both have a 2x in common. 2x minus 5 just has a positive 1. Now go down. 4x squared and 2x both have a 2x. Negative 10x and negative 5 both have a negative 5. So my factors become 2x plus 1 and 2x minus 5. Once I have that, I set each one equal to 0 and solve. So minus 1 and divide by 2. Over here I'm going to add the 5 and then divide by 2. So 5 halves and negative 1/2 Again, 2.5 and negative 0.5 if you would like to make those decimals. Okay. On 25, on 25 it is asking you to find the solutions, and it's set up to where it's in the quadratic formula, so I need to make this 8 move to the other side. So minus 8 equals 0. So it's asking me which of these matches my quadratic. So if I start this, a, b, and c, so x equals negative b, but it's already negative. So 15 squared minus 4 times a times c, all of that divided by 2 times a. Well, right away I can look on the bottom, and 2 times a negative 3 is going to give me a negative 6, which means my denominator should be a negative 6. So should be a negative 6. So right away I can go ahead and get rid of a and b. If I look right here, this is a positive. So I can eliminate c, and I know that my answer is D. Okay. So the same thing with 26. I need to make this equal 0 first. So negative x squared plus 4x plus 12 equals 0. So then a, b, and c. So x equals a negative b plus or minus the square root of b squared minus 4 times a times c, all of that divided by 2 times a. Again, if I look, my denominator, 2 times negative 1 should give me a negative 2, so I can eliminate a. This is supposed to be a negative 4, so I can eliminate d and b, which leaves me as C is my answer. Okay? Make sure that you go through and check these and check your work. On 21 through 24, even though I factored and used DOPS or GCF, you can use the quadratic formula to solve every single one of those. It's just going to take you a little bit more time. All right?